Till now, we have covered the concept of API ingestion and the database ingestion. Now, third source is the file-based ingestion. File-based ingestion means when we are directly importing the data from different types of file format. Mostly you people have used the CSV Excel format, and when we ingest the data through the CSV Excel, this can also be considered as a file-based ingestion. So there are different types of formats available in the file-based. CSV, Excel, these two are very common format. JSON is also an important format. Usually we have studied the JSON from the API as an output from the API. But here we will study the JSON as a file format. XML, TST, log. So log is when we store the logs. What do we mean by the logs? The activity of any server or any workflow or any process. That thing is stored in the format of a log file. It is also a very important data type, and you will study this data type in intensive manner in subsequent lessons also, because whenever we will do the data engineering, then studying the log is very important. So how this works? From the source system can be anything. It can be AWS, Azure, even Teams, SharePoint, Google Drive. From there you will import the files to the ingestion pipeline. Ingestion pipeline is built in the Python, and where we are storing that into a database. Now question arises, from where we will get this kind of data? Kind of data, what do we mean by the kind of data? In a data which has the file format. For example, your company, one department is using the traditional format. For example, sales department is still using the traditional file-based format. And from there you can get the file-based files. Then vendors, from the vendors, company has many vendors. Maybe vendor don't have the today's time technology. He is using the Excel or the CSV file. SaaS tools, banking systems are very secure, so they can be used different kind of file formats, and they will use the files over the mail or over the Teams. So these are the major you can say data sources, some examples of the data sources. Now we will study the different types of file formats and how we are storing them. First one is the CSV. Many of you have used the CSV format extensively, CSV and the Excel format. We will use the pandas as PD, and then from the pandas we will use the read_CSV function. From there we will pass the file path. In the file path we will change the backward slash to the forward slash. Just keep that in mind, change the backward slash to the forward slash. You will copy the path. How we can copy the path? You can either directly click here in the top. Here you can get the path, or you can simply select the CSV sample here. Properties. Above the property we have the copy as path. This function. Copy as path. In the GitHub, I have uploaded all the files, notebook files plus the data files for the practice. You can easily download the data files and the code from there. For the GitHub repo, you can see the repo name in the description. Now there is one more point. Not every CSV uses the commas. Sometimes it can use the pipe tab of the semicolon. At that time, you will specify the delimiter equal to pipe, or delimiter equal to space, delimiter equal to tab, or delimiter equal to semicolon. There are different types of delimiter available for the CSV format also. Not necessarily it will always follow the comma. The most common type is the comma only. Now in second one, the Excel. In the Excel, you will specify the function read_Excel. In that same method, you will copy the path of the file. This is the file which you will be using. In this file, you will specify the sheet name which you want to upload. If you want to read multiple tabs, then don't specify the sheet name. Sheet name equal to none. Then it will load all the data. For example, we have the 3 sheet. Let me show you. Here we have 4 tabs, and when you specify sheet equal to none, sheet name equal to none, then all the 4 tab will be loaded into the data frame. Then all the 4 tab will be loaded. And where it will be stored? It will be stored in the object all underscore sheets. Now to fetch the each data frame or the each tab from the all sheet, you can easily specify the for loop. Here in the for loop, first you will use the sheet name, the name, comma data. Okay, sheet name, comma data in all sheets dot items. So what you will get in the sheet name, you have the name. For example, first is the customer. Inside the customer, we have the data, complete data set. Here you can see customers, the sheet name, first print, then second the data dot head. By this way, you can easily import all the tabs of the Excel file in a one go, and you can also store that into different data frame. For each tab, you can generate the data frame. Just you need to add one or more step. You can add one more step here, and easily we can specify the data frame for each data set. Now, if you want to skip number of rows, the first 3 rows, there can be a time when your first 3 rows don't contain any value. After the first 3 rows, data has been started. Let me show you in the Excel sheet. Here, data is starting from the 4th row. So you can easily skip the first 3 rows. For that, you have to specify the parameter skip rows equal to 3. Now come the TST file. TST, the test file. Sometimes the CSV and the TST file are almost similar if we are storing the Excel kind of data, because there also we specify the delimiter as comma more usually. So here what we are doing, we are reading the data here. You can see from the TST file. This file is also available in the dataset. You can download from the GitHub. But here we have to specify the columns. tf.columns equal to the 3 columns. Function is the same which we are using for the CSV. Now sometime in the TST file is a test file. So we know in the test file it can be sentence, written sentence or something like that. And we know that after this space we have the another column. After this space we have the another column. There are no comma. In the earlier example we were using the comma as a delimiter. But here we are using the fixed bit. But here we are using the width of the space. Like how many space are there. So first column is after the 3rd space, then after 10 space, then the 10 space or the 10 element you can say. Okay. So let me show you the file. Customer split. Here you can see. After 3, we have in the first 3, we have the first column. In the first 3, we have the first column. Then till 10, we have the next column. Then again 10, we have the next column. Okay. Now there is the another format JSON. For the JSON format, we will use the function read underscore JSON. Now main concern arises when we have the nested JSON. To understand the nested JSON, let's open this file. Here you can see order ID. After the order ID, inside the customer, order ID is one, you can say attribute. After the order ID, we have the attribute customer. Inside the customer, we have the name and the city. So it is an example of the nested JSON. To deal with the nested JSON, what we will do, we will use the function with open. With open is the common function to open the file. Here you specify the mode, read mode as file. Then data equal to JSON.load. Here we will load the complete data, and using the JSON normalize, it is a very important function. This will convert the data into the actual data frame. So major step is here you will use the with open function and the JSON normalize. Then the example is the JSON lines. This is the very important, you can say, data format here, file format. Sometimes logs and the event data is stored in this kind of format. Let's understand this. Also, point to be noted here, it is the JSONL. In the JSON, it is only JSON. Here it is JSONL. L signifies the lines. In each line, we have the one data set, or you can say the one row, not the data set, one row in each line. To import this kind of data, you can use the read JSON and specify the lines equal to true. So it will load the data from the JSON line format. Now comes the XML file. It is some old kind of data format. It is not used as much now, but we should know how to deal with this kind of data because some legacy system still use this. Read XML is straightforward function. Now let's see how this data looks. Now come the log file. Log file, whenever any process runs or you are doing any task. Now in the later lecture we will cover the concepts of the workflows or the airflow systems. Their logs file are generated. So how we are storing that log file and how to read that log file, how to extract the important attribute from that. So to do that, we need to understand the working of a log file. Here we will use the with open function. With the with open function, you can read the log file directly. In each line, we can get the logs. Each step is stored as a log. For example, you are storing the data from you can say AWS to your local database system. So kind of example. In doing that, there can be multiple steps. So each step will be displayed as a log and it will be stored in a log file. You will open the log file using the with function and each line will be used to extract the attributes. Now take the one line for example. This is the line. In this line we have the first date, time, then whether it is error or the success, okay, then message, and in the end we have the user ID. So we have almost 5 parameters. First one is date, then time, then you can see the level, then message, after message user ID. These 5 important attributes or the information you can say is stored in this line, and there can be hundreds of lines in the log file. So you have to store this in somewhere to understand whether a process is successful or what happens to your process. To understand these concepts, you have to store this log file. Now, this is the regress expression for finding out the patterns. You can see D4 means year, D2 year, month, and D2 day, then D2 hour. D2 means there are 2 digits. D4 means there are 4 digits. Then this is W means there will be a message here in the text format. Then again here D. D means there can be a number here. Now we have defined the pattern, the regress here, and using this pattern we will find this pattern where in the log line. So in re.match we have imported the function module re. Re is a regular expression module. From the re we will use the function match. Match will do? Match will use this pattern and find out the pattern in the file or in the line where you want to find that pattern. We want to find that pattern in this string, the log line. So it will find out that pattern here in the log line match. What it will do, you can notice here, there is the parenthesis. One set of parentheses 1, 2, 3, 4, 5. So if you come to the if function inside the if, this is the group 1 where we have stored the date, and that is signified by the parenthesis. And inside that D4, D2, D2, it will find out that pattern, and that pattern, using that pattern, some value you will get this value, and this value will be stored in the date. Similar for the time, then level, then message, then user ID. If you have any doubt or any question, then you can easily ask me in the comment box or through the mail. Now reading these large files in the chunks is a very important concept, because in the actual world you will not get a small files. There can be a 1 GB file or multiple lines file. How to import that file in a one go can be a very tricky task. So to do that, what we will do, we will divide the data into small chunks. Chunks means into batches. How we are doing that? We are trying to read the CSV file. For chunk in read CSV path, chunk size, you can specify the chunk size 5000. It is your choice what you want to specify. And that chunk will be appended into an empty list. After that, using the concat function, data from pandas concat function, you can combine all the chunks. You have to know the index, because if you don't do this, then there can be a problem. So this is a very simple example of loading the data into chunks. So in today's lecture, we have covered different types of file formats and how to load that data. Thank you.